Solve applications involving scaling. All right, let's jump in. So the map shows a ratio of 1 inch equal to 85 miles. Two cities are 340 miles apart. How far apart would they be on the map? Now, I don't know the last time you actually looked at a paper map, but they're pretty cool. And usually in the bottom corner, there's like this thing that looks like this, and it shows like, this would be like 1 inch, and it would say like 85 miles, right? So it kind of shows the ratio, right? So it's kind of a cool thing. Play with paper maps if you have it. But anyway, let's get to scaling, right? So the scale is 1 inch to 85 miles. And when we're thinking about solving a problem, this becomes proportional, right? So we are comparing inches to miles. So I'm going to put inches in the numerator and miles in the denominator. Doesn't matter which way it goes, just be consistent. So 1 inch is 85 miles. That is one of my ratios in my proportion. Now, the two cities, right, on a map, that's what we're trying to find. But in real life, we know these cities are 340 miles apart. Now, since miles are in the denominator, 340 is going to go in the denominator of my second ratio. So when the question is how far apart would they be on the map, we know that the map is in inches. So we are trying to find the unknown value here. Now that we've set up our proportion, we can cross multiply. So 85 times x is 85x. 340 times 1 is 340. Now to get x by itself, we are going to divide both sides by the coefficient of x, which is 85, because 85 divided by 85 is 1. So I get 1x equals 4, and it comes out nicely. So in this case, the two cities would be 4 inches apart on the map. Make sure you're paying attention to labels. So when you have your answer, you should know, okay, this is in inches, put inches. Make sure we know what we're talking about. A model car. Okay, so if you've ever gone to a store and you're trying to buy a model, there's always a scale on the box. So this model car shows a scale of 1 to 14.5. If the model has a tire with a diameter of 1.5, what is the actual tire diameter? Round to the nearest tenth. And I know we're not dealing with units, but this is just to get an idea of how scales are used. Okay, so think about this. We have the ratio of 1 to 14.5. Generally, models are much smaller, right? So we know that this is the model and this is the actual thing, 1 to 14.5. Okay, so then when you say the model has a tire diameter, okay, so this is the model. Model goes in the numerator, and I'm trying to find the actual tire diameter. What is the actual? So I know the x goes in the denominator. Once again, to solve this, I cross multiply. So 1 times x is just x, and 14.5 times 1.5 is 21.75. So this is the actual tire diameter. And I don't have units in this one. I just know that it's the actual, right? Always make sure you know what your answer is. Units are great, but at least know what it is. And that is solving applications involving scaling.